In this segment, I want to get into Wii RAM hacking. Now, I've covered the USB Gecko in previous segments. If this is the first time you're hearing about it, it is a device that was created for the GameCube and the Wii that plugs into the memory card slot and allows you to have a USB interface to do various debugging and development features. It's really great for homebrew, and if you have a real interest in any of the GameCube or Wii homebrew, I'd highly suggest getting one. Now, before we even begin, we have to have a slight understanding of the inner workings of the Wii. The Wii itself has 88 megabytes of memory. Only 24 of those megs we're really interested in. The Wii does partition the memory into a Mem1 and Mem2 range. I'll put some links in the show notes that explain the memory ranges of the actual Wii itself. I'm not going to get into it today. But you have to understand that there are certain ranges of addresses that if you poke at it, it'll instantly crash the Wii. Reason being is that the Wii does have encrypted parts of RAM. There are two main CPUs inside the Wii itself. You have the Starlet, which when you first power up the Wii, it sets up all of the communication, the encryption, it sets up the controllers, it sets up the entire environment, and then makes sure that everything is a secure session, everything is encrypted throughout the ass and back again. And it puts itself into small ranges of memory. Now, once everything is authenticated and secured, it hands control over to the Hollywood CPU, and the Hollywood CPU will execute the code and let you play your game or your homebrew. Now, the problem with this is if we actually read or write to any of the contents of RAM that the Starlet's execution code is in, or is residing in, or any encrypted RAM for that matter, it'll instantly lock up the game. Also, you can peek into not only the actual RAM for the system RAM, but you can also poke into the graphics RAM. So sometimes a game might be using system RAM to hold graphics data, and just by reading it, causing that lag, when you dump the data, it's going to crash the system. So when you first get started, do a lot of research on the USB Gecko forums. There's a whole community of RAM hacking people behind this, and they've got a lot of great information already out there. I'm going to link to them. We'll put it in the show notes. Now, before we even get into the actual console side, we have to understand object-oriented programming languages. Now, typically with NES hacking, the game itself actually resides on a flash cartridge. Everything is all in that one area. And we always know that the RAM addresses are always going to be the equal no matter what, no matter whenever we load a stage or wherever it's going to be, everything's on that media. But today, games are held on CDs or DVDs. There's no way to put like a 700 meg CD in the contents of only 88 megabytes of RAM. So when we have a 3D game, it's what we call an object-oriented language, meaning everything in the entire game is considered an object. Like an example, let's say that my entire room here is a computer simulation. My remote control is coded and compiled as one object. My laptop here is one object. I am an object. The camera is an object. The tripod stand, an object. My tables, they're objects. Those objects will load into memory, and in those objects themselves will contain actual memory locations. Now, when the game's loading things in the memory, today we're going to focus on Super Mario Galaxy for obvious reasons, and I'll explain in a little bit. Now, when the game is actually loading in the memory, the first thing that should load is the stage. So sometimes the stage could be 5 megs, maybe it could be 10, maybe it could be 50. You don't know until it loads. So when Mario finally, which is going to be the obvious character you want to have your attributes for, when Mario loads into that level, the memory addresses in which his health and his lives and star bits and coins will never be in the same location twice. This is an obvious thing for any object-oriented language, because when things load into memory, it goes first in, first out, or what's called FIFO. And the FIFO buffer basically means is the first thing that goes into the RAM is the first thing that comes out of the RAM. So the first thing that goes into the RAM is going to be the level. So if the level takes up, say, 10 megs of space, and then Mario takes up, as an object, takes up 1 meg, he's going to be at the 11 megabyte mark. But what happens if your level takes up 15 megs? Mario will start at the 15 meg limit and take up 1 meg. Argument's sake, I'm just trying to make this easy. So this is where pointers come in. Now, the first thing that really loads to RAM is what's called a pointer list. So think of it like this. If a game is compiled as an object, then each object is like a book perhaps, where there are chapters. You might not know where those chapters are unless you manually look through. But if you look at the index of the book, it'll tell you where all of the chapters start on what page numbers. That's what a pointer is. The pointers are an actual list of where the actual object will reside in RAM, and where in that object file, in a memory offset, where to actually find specific values like health, coins, what power-ups you have, and a whole bunch of stuff. So typically with the NES RAM hacking I've done like 20-something segments ago, we just basically would dump the RAM and we'd compare and contrast, and we'd look for different differences in values, like, you know, more than, less than, equal to, not equal to, specific values and such. So go back to those segments and check out the basic techniques for RAM hacking. Those will be applicable to this. Today, I'm going to get a little bit more in depth. I'm going to automatically understand that you have a clear understanding of binary, hexadecimal, as well as the decimal numbering systems, 8, 16, and 32-bit string formats and variable formats. I'm automatically going to assume that you know the basic concepts of how to dump the RAM, use a utility to compare two sets of RAM to find the differences, to find the addresses you're looking for. All of that I'm going to assume you already know. If you don't, hit previous episodes. I'll put links in the show notes on basic concepts of that. So we're going to go and load up Mario Galaxy and the Gecko OS, and we're going to get to the PC side and get to a brief tutorial on how to start Wii RAM hacking using Super Mario Galaxy. Go ahead and load Gecko OS by way of choice. I plan on using the Wii Homebrew channel, and launch the weird graphical user interface. It'll automatically launch the game. So, brief overview of what you're seeing in front of you. The interface has the next step and run button. Once the game actually loads, you can either hit next to go and increment one CPU cycle, or you hit run to resume the actual game itself. If at any time you need to pause the game because you're in heavy action or just whatever reason need some time to think, you can go ahead, hit the pause button. Top left, we have the memory ranges that we're allowed to play in, which I'll put some links in the show notes about. And it also automatically fills in the start and end addresses that are safely allowed to actually play in. Now, we can actually do a search of a value type of an unknown value using, you know, the particular equal, not equal, less than or equal, you know, the typical, you know, compare types. Or we can actually load, we can search for specific values of either 8, 16, or 32-bit values. Later on, we'll be using the pointer search, the memory viewer, as well as the GCT codes, but we'll get into those when the time comes. Go ahead and load up Mario Galaxy and get to the primary observatory place, and if you notice on the screen, I have 9,852 star bits, so we're going to go and start searching for things. So we're going to search for a 32-bit value of 9,852. Now, of course, this is in decimal, and we want to work in hex, so we hit the convert decimal to hex button, and it'll convert it to 267C. We're going to go ahead and start. It'll take about 45 seconds to dump 24 megs of data, and the Wii is going to lock up, it's going to freeze and make a horrible bunch of noise, so mute your TV, and then just bear with us. Alright, the search is done, and we are left with only 6 codes, which is pretty good. Every once in a while you'll have a couple of tens of thousands. So we're going to go ahead and we are going to use 2 star bits, and we are going to put in the number in decimal, 9,850. We're going to convert that to hexadecimal, and we're going to search again. Okay, we're only down to 1 address, so when you get down to a couple of addresses, it's time to do some nitty-gritty poking around. You can right-click the address, and then manually hit poke. Later on, we'll be using the memory viewer, pointer 1 and pointer 2, but for now, we're going to poke. And if you'll notice, it's at the previous value of 267C, so we're going to go ahead and poke it. And there we go, it actually goes up.
bring it back down to A. There it goes. Fine and dandy. It goes to show that now you can poke this specific memory address as a 32-bit value. So now that we can go to the GCT codes, and we're going to make a new code. And we're going to name this code, if it lets me rename it, starbits. And going to the US Gecko's website, they actually have an in-detail tutorial on how to use, or actually an explanation, I should say, it's not much of a tutorial, on different memory ranges, base addresses, pointers, registers, such and such and such. So, right now we're actually interested in locking a 32-bit value at an address, at a base address. So, let's see, this is 16, no, we want 32. So, alright, so our prefix is going to be 04, which means to write 32 bits into the RAM of the base address. Alright, so we'll go back to the weird graphical interface, and I've actually already put together this code. Where did it go? I do believe it's this one. Give me 1 second. I'm just trying to copy and paste here. Here we go. Make sure that these are proper addresses. F6, 3C, F4, 36, and alright. Alright, so 04 is the prefix saying, as stated, 04 is 32-bit RAM write at the base address, and we found the base address quite easily. And the base address being F6, 3C, F4, and we want to lock it to the value 270F, which should constitute as 9,999. So we're going to add the code to the star bits, and then we're going to enable it. Hit enable, and we're going to apply the codes. And there we go. Our first code. It's going to lock the star bits to 9,999. So once this is done filling up, I'll actually show. There we go. Doesn't matter how many you use, this code is going to automatically lock this base address and fill it with a 32-bit value, decimal 9,999, or hexadecimal 270F. So this is our first basic search. Alright, all fine and dandy, now we know how to find base addresses, but what about these elusive pointers that I was talking about? So we're just going to go ahead and fly to any random galaxy that we can start doing searches on pointers. Now, to get a pointer, we're going to have to load up 2 separate worlds, and we're going to have to find the same, a different address for the same thing. So the easiest thing to look for is health. So we're going to go ahead and restart everything, reset all of the values, and we're going to start on Mario's health, and we want a 32-bit value for decimal 3, 32-bit 3. Because we know he has 3 health right now, we're going to go ahead and do a quick search. Alright, so we're down to 5,707. That's a bit, so we're going to lose a bit of health. And you can use the typical compares of equal, not equal, greater than, less than, but we know the value is at 2, so we're going to search again for 2. Alright, we're narrowed down to 6, but I'm a stingy bastard, so let's try to get this down to a few less. Reduce the health by 1, and search again. Now that's more like it. We're down to 2 addresses. Now we're going to go ahead and poke. We'll poke this first address, and every time we poke it, we notice that the life meter on the screen just jiggles, so that's obviously not it. We'll poke the other address. And we've got it. And we'll make this 3, bring Mario's health back up to 3. Verified that this address for this world is Mario's health. But if we change worlds, because of the way object-oriented programming works, it won't be the same for another world. So we need to find a pointer. So we're going to enter this address into pointer search 1. And if you, sorry, let me narrate. You right-click, and you go to pointer 1, and go to the pointer search, and you'll notice that it'll enter in address 1. Then go to the memory dump, and do 1 memory dump for this stage. Alright, once the memory dump is done, I've noticed a small problem with the weird interface. You actually have to go and click File 1 and manually point it to the actual dump180.bin. Now, we've manually found the address for Mario's health for this level, and we've entered that address into the pointer search. Now we have to go off to another level so we can find the alternate address for another world so we can compare these two different files for pointers. Alright, we're going to go and fly over to a separate world because, like I said, when it comes to object-oriented languages, things don't always go into memory the exact same time twice. So, we've got the previous memory address in memory, and we're going to go and try to poke it at 02. And if you notice, Mario's life isn't going down. Like I said, because of the object-oriented language, we can't always use the same address that we find in the world. We need to find the pointer. So we're going to go and, again, look for Mario's health, and it's going to be decimal 3, as well as hex 3, and we're going to be in the 80 memory range, and weird automatically puts in the safe ranges that we're allowed to play in, and we're going to do a preliminary dump and see if we can find the memory address of Mario's health for this specific level. Alright, well that narrows it down to about 7,296 possible values, so I'm going to go get hurt. Come on. Now we know his health is down to 2, and we'll do this again, do another search. Alright, so we're down to 3 values, so I'm going to assume that this last value here is going to be it, because that's how it was the last time. I'm just going to make an assumption. We're going to go ahead and poke it. And there's Mario's health. Alright, we're going to bring it back down to 2, just to verify. Alright. Bring it back up to 3. And then we're going to enter this into pointer 2. Now, this is the address for the Mario's health in the first level, and this is the second level. This is the binary dump from the first level. We're going to do a binary dump of this level. Alright, once it actually resumes, you manually have to go and tell it exactly where the files are. It's a little glitch that's in the weird interface that'll hopefully be fixed sometime soon. And then hit your search button. And what it's going to do is it's going to manually compare both of these binary files as well as the addresses that you specified to actually look for possible pointers as well as their offsets. So we've got a couple of results and a couple of best results. And we'll take a further look into this right now. Alright, I just moved Mario over to a nice safe spot so he can't get hurt and nothing else in the variables can change. And I've already done some poking around previously, and we're going to go ahead and look at this 806B7B40 pointer address. And we're going to copy this. And notice how it has this plus 380. That's telling us the offset. So it's telling us that within this memory address, and this pointer and offset should contain Mario's health. So we're going to go to that memory address. This memory address is leading us to another memory address. So this is the pointer. And this is where the pointer is leading to. And the pointer is leading us to 810B2ED0. So we're going to copy this down, and we're going to load up calculator. Good old calculator. And for those of you who don't know, you can hit the View button and go between Scientific and Standard View. We're going to go into Hex, and we're going to paste in using Control-V to paste and Control-C. Don't know if too many of you know about those shortcuts. And we're going to add, in Hex, 380 as the offset. And we're going to come up with this new address of 810B3250. And we're going to Control-C to copy this, and we're going to go back to the weird interface. We're going to put this in the memory viewer. Actually, you know what we can do is we can just poke it. Let's just do that. Control-V. And we'll poke it. Poke this as 2. And look, Mario's life goes down. We'll poke it as 3 again. So, if we go to the memory viewer, Control-V, there it is. There's Mario's health right there. So now we know that the pointer for Mario's health is 806B7B40 plus 380. So we're going to go to the GCT codes, and we're going to make a new code called health. And we're going to go ahead and look at the USB Gecko code list at 48, which is the load into pointer, which means we want to load the pointer address, and then the next code will manipulate the actual address. So, I've already got the code created on the sidelines. So 48, and then you fill the rest of it up with zeros, says we want to use the pointer address 806B 7B40 as the primary pointer address. Awesome. And then we want to use the 14 prefix code, which says to use the pointer offset, PO meaning pointer offset, and BA meaning base address. So we're going to use 14 as the prefix and 380 as the offset, because the pointer search is telling us to use 380 as the offset. So I've already created this code. We're going to copy it, and we are going to paste it like so. Now, there's one more code that you have to do. Usually when you're doing pointers and offsets, you have to reset it. And if you read the documentation, it says to use the following code, E0, and then pad the rest of it with zeros, as well as 8000, 8000. And this is going to reset whatever pointers when the code is done executing. So we're going to go ahead and we're going to leave this world, and we're going to verify that that this is the actual pointer we're looking at, and then make sure that this code is going to work. Alright, we've entered a new world, and we know that this following address, when we go to the memory viewer, is going to lead us to where the pointer address is. So this is going to be the pointer address, and that's going to point to another RAM address, and we're going to take that RAM address and add 380 in hex to it. So where's my calculator? I'm going to clear all this, Control V to paste, and we're going to add 380 in hex, and it's going to lead us to a new address, Control C, and we're going to go back to Weird, and we're going to put this in the memory viewer, and notice, it looks like it's the right value, so we'll go to the pointer search, the poke window, Control V to paste, and we'll make this 2, and we'll poke it, and hey, look, it worked, which means we did find the valid pointer. So we can go to the GCT codes, which, if you really don't want to get into all of this, cheat code hacking and all this jazz, you can go to the USB Gecko forums. They have a whole community, a lot of really cool people that know a lot more about this than I do, so really don't try to bombard me with a lot of questions about this. I'm still doing a lot of learning. Go to the USB Gecko forums, because there's a much bigger community of Wii console hackers than there are on the BSoD forums. So, we've got the code in place. So 48 prefix tells us that we're going to be using a pointer, and we're setting the pointer as 806B7B40. The 14 prefix code says to add the offset of whatever value. In this case, 380. It's telling us to use 380. So we set that to 380, and we want to set the maximum value to 3. And 3 is too normal. Let's make that 6. And then we have to use the E0 code to actually reset the the pointer offset so it doesn't crash the console. So, let's go ahead and enable this code and hope to God, once we hit apply, it doesn't crash. Hey, look, and it doesn't. So you know what? I'm going to go ahead and just, without any editing magic, I'm going to go to the observatory again. I'm going to go to a completely new world, and I am just going to get hurt and see how badly I can get my ass whipped, because I know a lot of people claim that a lot of videos on the internet are fake these days, and I really hope through BSoD you've gained a little bit more faith through the actual legitimate hacking communities and a lot of the hard work that they're doing. And I'd like to thank everyone on the USB Gecko forums, as well as the USB Gecko team, for creating these wonderful tools and utilities that none of this would be possible without. So, I'm going to run around and see what I can do to get hurt. And I'm not getting hurt. This code has told the we found the pointer address, which leads and the offset, and we've locked it to a maximum value of 6. So essentially, now we have unlimited health. Now you can also affect characters, animations, how many coins you have, star bits, but there is a lot to actual Wii RAM hacking. This is just going to be the basics. I hope I really inspired you guys to be a little bit more insightful with what you guys want to do with your Wii. And, you know, I'll put a lot of information about the discrepancies of what ranges of RAM you can and cannot access in the show notes, and I'll try to put as much in the show notes as I can. I'm really hoping that I'm not running out of time on this. This segment has been kicking my ass, so for now, I'm just going to say, you know what, have fun and good luck.
Today I'm going to talk to you about the thumbs.database file. Starting with Windows Millennium Edition and then again in XP, Microsoft incorporated a thumbs.database basically where Windows will cache a thumbnail image of what's in your folder. If you ever notice with newer versions of Windows, you'll see like images inside the folder will be the actual icon and stuff. That has to do with the thumbs.database file. What a lot of people don't know, because it's hidden, they don't know it's there. Naturally, Windows, it's a hidden file in Windows. So they'll upload shit to Usenet or torrents or whatever, and next thing you know, they don't know they're sending a thumbnail image of whatever was in that folder. It doesn't always update or change, so even if you deleted something that was in the folder, it might still be on the thumbnail image. So if you find one of these thumbnail images, well, why not fuck around with it, see what you can find. Download a program called it's called Thumb Viewer. I'll put a link up on the screen of where to download it, and I'll put it in the show notes. But anyway, it's a straightforward program. Just download it, unzip it, and then double click the executable. Very simple. Drag and drop the files right in here. So if you want to look for thumbnail images on your hard drive, yeah, sorry, I can talk today. Go to the search function on your computer, files and folders, and just type in thumbs.database. I already did down here somewhere. Yeah, there's my results. So I get a couple different thumbs.database files here. Just click them and drag them into the Thumb Viewer program. As you can see, we can see images that were in that folder before. Do I have anything interesting on here? No, I don't really have anything interesting, but as you can see, it pulls images out of the thumbs.database folder. Now, what can we do to protect ourselves from this? Well, very simple actually. There's a registry setting you can do if you really want to. I'll list that in the show notes. I'm not going to show that here. But the easiest thing to do would actually be just open up Windows Explorer, go to Tools, then Folder Options, and View. And go to, where does it say? Sorry. Do not cache thumbnails, right here, if you can see. Just check that, click Apply, and it'll stop caching thumbnail images. Now again, if you want to delete all the thumbnail images on your computer, easiest way to do it, there's a freeware program you can download that will actually seek out all the thumbnail images on your computer, and you can delete them, but I can't see installing a program to do something like that. Again, just search Files and Folders, all folders, type in thumbs.database. My typing's horrible. And when it finds them, just select all of them and delete them. It's the easiest, simple way to do it. And I hope that helps you. If not, skip ahead to the next segment.
Howdy, Ugster here. Today I'd like to go over some basic smartphone and more specific Motorola Q tweaks and registry edits to make the phone a little bit more usable and the interface more easy to navigate. TechCentric did a short segment on the Motorola Q. They covered 3 hacks specifically. They did the glyph cache, which basically tells the phone how much memory to allot to frame drawing everything on screen and such. I didn't notice too much of a speed increase. for my Motorola Q just didn't really do much for me. Other people have had a lot of success with it, depending on how much memory your phone has. You know, I don't know. For me, it just didn't do much. They also did the SMS notification, turn that off, which is a really annoying feature in Windows Mobile 5. I don't know if it's in 6 because I don't have anything that runs Windows Mobile 6. But every time you send a text message, it'll pop up a notification that says SMS sent. And you have to click OK before you can do anything else. It's just really annoying. So they also covered that. And the other thing was the CPU speed. Normally, for the Motorola Q, I'm not sure if it's the same for other smartphones, but it will scale the processor speed. So depending on what you're doing, it'll either speed it up or slow it down. If you're playing a video, it's going to go at the full clock speed or close to it. If you're just editing a text file or sending email, it's going to slow it down, obviously, and that's to save battery life. They changed the registry setting to just have it run at the full 315 megahertz for the Motorola Q. I don't know what effect that has on CPU or on battery life, but you know, that's just how it is. We'll put a link to that in the show notes so you can check it out yourself. I'm going to cover some more user interface, like I said, and at the end of the segment I'm also going to show how to add Flash support. There's a couple different methods to get Flash in Internet Explorer, Pocket IE, as well as some alternate little tweaks and stuff to do that. So I'm going to go over the computer and I'll get some screen caps going on my phone so you can see what the crap I'm talking about. Alright, so first we're going to look at a couple registry editors for the smartphone platform. First we're going to look at PHM Registry Editor. This is a cab file for smartphone and PPC. You edit the registry on the phone using the keypad and the directional pad. It's pretty clunky and it can get annoying, especially if you're digging really deep and adding strings or keys. Another one I use a lot that we're going to be using primarily today is the Mobile Registry Editor. This is another freeware application and it allows you to edit your registry on your smartphone or PPC from your desktop, just like you're editing the registry for any Windows XP or Windows 98, whatever. It's a lot easier to use, and it just syncs using ActiveSync. Now, word of warning: you do have to restart the phone whenever you make any registry edits for them to stick. Sometimes you have to wait a couple minutes after editing it to restart. So if you're tweaking stuff, you have to make the edit, wait a few minutes, soft reset, and then make sure that it's stuck. If it didn't, wait a little longer. You know, if not, I can't help you. So we're going to be looking at Mobile Registry Editor, and this is it. Looks just like the registry editor on your desktop. In fact, I'm pretty sure it's actually based on it. So everything's here. You know, it says Motorola Q. That's my phone. Connects to it. I used PHM Registry Editor for the longest time. Made so many mistakes and screwed stuff up. And then I found this program. It makes it a lot easier to use. So yeah, this is taking way too long. I'm going to cut over to a couple different shots of specific registry edits and what they do. Alright, so the first one we're going to look at is changing the start menu from grid view to list view. This is useful if you have a lot of icons in your start menu and you need easier access to them. It'll display a lot more icons on the screen, and it's easier to navigate for me. So the key is H key, current user, software, Microsoft, shell, start menu. Now there's D word value for grid view. 0 is list view, 1 is grid view. I have it set to grid view now. I'll show you what that looks like. So this is obviously a screen capture of my phone, in case you didn't catch that. And this is the list view. Everything's nice and organized, and there you go. Also, you can set it to hide labels. That's another D word value. I didn't change that because a lot of these don't have icons, so I didn't change that personally, but if you'd like to, you can. Next, we're going to look at shutting your phone up and making it stop making annoying sounds. Yes, you can go into sound settings and set it to vibrate, but it's still going to beep when you make a call, it's still going to beep when you take a picture, and it's still going to have a startup sound. I'll show you how to disable those. First, we'll start with the startup sound. It's H key, current user, sounds, and system start. Now the sound string normally has \Windows \piano.wave. You have to change that to *, none, that, and that disables the startup sound. The next one, no camera click. This is specific to the Motorola Q. So you're going to have to look at some different registry edits. I'm sure it's out there to disable the sound if there is any on your specific phone. So the key for that is H key, local machine, system, pictures, camera, OEM, and then you just change the sound file string to \Windows \, none, asterisk, yeah, that star looking thingy, and that disables it from making a shutter sound. Finally, we will look at disabling the beep when you go to make a call. I find that extremely annoying, but sometimes I haven't disabled that one personally yet, because sometimes I just won't know if my phone's making a call because it lags a bit from when you actually pick the contact and push the button to make the call. So that beep just kind of reassures me that I'm calling people. So the key for that is H key, current user, control panel, sounds, dialing, and then you change the value for sound string to none. So you change this to asterisk, none, asterisk, just like that. But I don't want to do that. Alright, so just from those few registry edits, you should be able to have a basic idea of what you're doing. I mean, if you can edit the Windows registry, you can do this. It's not very difficult. Word of warning, don't edit anything you don't understand. If when in doubt, Google it. And if you still don't understand, you shouldn't be editing the registry in the first place. If you brick your phone, I'm going to laugh at you. It's as simple as that. Like I said, Google it, search the keys, strings, values, whatever. There's a lot of information out there. There's a lot of resources. I'll try to put some links in the show notes to Motorola Q specific registry edits, as well as generic smartphone and PPC. I'll try and cover as much as I can, but like I said, I've only got one device, so that's all I can play with right now. Moving on to Flash support. This is something that I struggled with for a while. It's something that you'd think would be there in the first place. It really should have been, but it's Microsoft we're talking about. No, it's not. So there's two ways to do this. If you want just YouTube and Google Video and a couple others, VO as well was supported, but since they went to suck, it just, it's not really worth it anymore. But there's a bunch of supported sites with that. This is basically, like I said, it's called a Flash Video Bundle. It's a cab file, very simple to install. You need a specific version of TCP/IP, and this program basically sends the file to TCP/IP. So if you're on YouTube and you click a link to a direct video, instead of going to the page with the comments and the alternate videos and the actual video, it'll give you a little pop-up menu that says play video, save video, or linked page. You hit play video, sends it to TCP/IP, buffers it, and plays it. You have to have a pretty good signal for this to work properly. I wouldn't recommend doing it if you only have 2 bars like I do right now. But anyway, it should work properly once you get buffering settings right, and it works. The other thing that you can do is actually hacking Flash into Pocket.ie. This used to be a really time-consuming process, and it was trial and error for me because I didn't have the convenience of a zip file and everything laid out right in front of me like I'm going to show you in a minute. Buttheads. Anyway, this actually adds Flash 7 support natively to Pocket.ie, so anything that has Flash will display on Pocket.ie. Whether you can use it or not is another story. Since it's a smartphone, it doesn't have a touch screen, obviously, so you need to use a cursor emulator. There's 2 main ones that work most of the time. One is called Fake Cursor. This is a free program. I haven't gotten it to work properly, actually. You start it up, and it shows the cursor, and you can use it, and it disables all the other buttons on the phone. So you can't do anything. I actually have to take the battery out to restart it. It's just how it is. You can't really control anything in Flash using the directional pad or the button. The other program is called SP Helper. This is a pay program, but it works really well. You assign it to a hotkey on the phone, and it brings it up or disables it as you need it. I've gotten the only real site that I've got to work with this Flash plugin is really homestarrunner.com, and that's because they use SWF files. So anyway, I'm going to show you how to use Flash Video Bundle first, and then I'll move on to the flash hacking. Okay, this is the Flash... Cut. Alright, this is the forum post for Flash Video Bundle. Once again, it's not very difficult to use, but make sure you read all the instructions and download the right version of TCP/IP for your device. There's a PPC version and there's a smartphone version. Not difficult. Also, make sure you install them both to the same directory. If you're installing TCP/IP to your device, install Flash Video Bundle to your device. And if you're installing TCP/IP to your storage card, install Flash Video Bundle to your storage card. This is an important step. If you miss it, it's not going to work. It's as simple as that. I told you so. So once you get that up and running, I'm not going to show you how to transfer a cab to your phone and run it. If you can't do that, go back to playing with Tinker Toys. So, this is my phone, and I'm on YouTube with the Flash Video Bundle installed. So I'm just going to select a video. Okay. Now normally when you press a button, when you press enter to go to the video, it'll take you to the link page, and it'll just say, "Hi, you have JavaScript turned off. You're an idiot using a smartphone. Go away. Microsoft hates you, and so does God." Now this, on the other hand, you push the center button, and it gives you a little menu. Play video, save video, or linked page. Linked page will take you to the linked page. Duh. Save video allows you to save the FLV file. It could take a while, but it'll save you from buffering it later. And play video. I'm going to see how this works. I don't know if it's going to play properly. It might just end up buffering forever and not actually play. But just to prove that it does work and that I'm not full of crap here. So it sends it over to TCP/IP. Like I said, again, you have to screw with your buffering settings a little bit to get it work. And there it is. Okay, I could get wrapped up in that for hours. So there's Flash Video Bundle. Simple to use, and that's the easiest way to get YouTube and Google video support on your phone. Next we will look at hacking Flash into Pocket.ie. Alright, a bunch of different sites have taken this from XDA developers and put their own spin on it and made their own tutorial, but like I said, XDA developers was the first one to come out with this hack. I'm using this site as an example because he has an easy to use RAR file, archive, that has everything listed and it's in easy steps, so it's hard to mess up. I'm going to try and go through it step by step because you do have to edit the registry and make some keys. There's no automated process for that, so you're going to have to do it by hand. Download the SP Flash hack and unrar it, and you will get this. There's 5 steps here. First one will be registry import, but like I said, there's no free program that I know of that'll import registry keys. If you find one, let me know, because that would make this whole process a lot simpler. Open up the registry entries in Notepad, and you will get this. This is a list of all the registry keys that would put in there automatically, but you're going to have to do this manually. This is the directory, HKey local machine, software, apps. Now, anything past apps in these cases isn't created yet. You're going to have to create the actual registry key. So this would be Macromedia Flash Player ActiveX, and then in that you're going to put 2 DWORD values, INSTL, DWORD value of 1, and INSTL directory continued, something, DWORD value of 1, again. And the rest of these are string values. I'm going to go to Mobile Registry Editor and try and show you more visually so it's a little bit easier to understand. It's not difficult, it's just confusing. So HKey local machine, software, apps. Let me resize this. And then I already created these, but you're going to have to do that because these aren't going to be there. So start with Macromedia Flash Player ActiveX because that has the most keys. It's the hardest. It takes the longest to put in. So you're basically going to right-click, New, Registry Key, type in Macromedia Flash Player ActiveX, watch the case, and make sure that you don't misspell anything. obviously. Just one of those basic things you don't want to overlook. You know, I mean, if it doesn't work, check that first. When you start your troubleshooting, check that first, because it's easy to, you know, one letter or one number off and it's not going to work. So once you get that in there, there's, like I said, there's two dword values, INSTL, and to create a dword value, right-click, New, dword value, word, and then put in the value data. Yeah, I know, screw you. So that's it. You create the dword values, again, watch case, make sure everything's spelled properly according to this. So INSTL is right here. Make sure you, yeah. So INSTL, dword value of 1. And the rest of these, same thing. Cab file. Yeah, it's just like that. Quite simple. So once you're done putting in all the registry keys, you're going to have to do that for Macromedia Flash Player 4 for the Pocket PC. That's simple. There's only one dword value of 0. And Macromedia Flash Player, same thing. Once those are done, soft reset your phone and go on to step 2. Now step 2 is copying a Windows directory to the Windows directory on your smartphone. I already did this, but I'll show you how to do it. Once your phone's connected through ActiveSync, you just go to Mobile Device, My Windows Mobile-based device, and then this is your phone or PPC, whatever. So there's the Windows folder, and then you just drag it from the SP Flash Hack folder, just drag it and drop it, and say yes to any overwrite dialogues. And then step 3, you're going to go into your Windows directory. Takes a couple seconds because it's the Windows directory. There's a lot of files in there. So once you get in there, you're going to overwrite. There's a folder in Windows, Macromedia folder. That's what you just dragged over. And in that Macromedia folder is a Flash DLL. You're going to replace that with Flash 6. So here it is. Okay, go down to Macromedia. And then here's the Flash DLL. You're going to just overwrite it. Yes, overwrite. Alright, so after you've copied over the Windows Macromedia folder, you're going to need to copy over the step 4, which is regsbrce.exe. This little program basically registers the Flash DLL so that whenever Internet Explorer encounters a SWF file, it will know to route it to the Flash DLL. Simple as that. So you just copy that over. I already did. You can't run it from here. You obviously have to run it from the phone. So I'm going to bring the phone up here. And using Total Commander or the built-in File Explorer, whatever, you're going to run the program and put in the path name for it. In this case, it's the same thing as right here. So it'd be /Windows /Macromedia /Flash.dll. I'm going to make sure it's on register and then hit OK. Okay, so it says DLL register server in Windows Macromedia Flash.dll succeeded. I'm going to hit OK. Now the last step to this whole big train wreck is to copy over the Flash 7 DLL and overwrite this one. So simple. Step 5, there's a Flash 7 DLL, just drag and drop. Replace the file, yes. Alright, the DLLs have been registered, the registry keys have been keyed, and everything should work. I queued up a Homestar Runner clip, and yeah, let's just pray that it works. Well, there you go. So that's pretty much it. It seems more complicated than it really was. I just ran into some unforeseen difficulties. But it's possible, obviously. I was able to do it. It's not very difficult. I wouldn't recommend using it if you're going to be looking at a lot of flash animations or trying to play SWF shockwave games. The smartphones really aren't even meant to play flash or FLV or SWF files in the first place, and it's a stretch to get them to do this. However, the Skyfire browser that I showcased in my last segment is definitely up to this task. I mean, it's got all the features you'd expect in a full desktop browser. I didn't get to get into too much detail in that, but it's got full flash support, full SWF support. It's handled just about everything I've thrown at it quite well. So if you're really interested in this, if you really want more multimedia in your browser, in your mobile browser, I would recommend signing up for the Skyfire beta. Otherwise, I'll put some links in the show notes for everything I covered today, the registry tweaks. I'm going to put some other websites up for you guys to look at. There's a whole slew of information out there that I wasn't even able to cover, just for time constraints, and I'm tired. So I hope this was informational for you guys, and I hope you really got something out of it. And if you'll excuse me, I got a date with a hot water heater.
In this segment, I want to get into Yagi antennas. Now, before I get into it, I want to say that building a microwave Yagi antenna is very difficult. And as we should all know by now, creating any form of antenna, the higher the frequency, the smaller your wavelength is going to be. Now, because we're in 2.4 gigahertz, everything has been down to like, a tenth of a millimeter, a half of a millimeter, something that's really hard to do. And with Yagi antennas, building them, especially with hand tools, are very difficult. Now, I don't want to discern you from this, but personally, I have not been able to get any kind of significant performance from a 2.4 gigahertz Yagi antenna. Now, the Yagi antenna was designed in the early 1920s by Professor Yagi, and that's about it. A basic Yagi antenna will look a lot like this, or your typical TV antenna. It's going to have a whole bunch of these horizontal or vertical elements, a driven element, typically of a dipole fashion, and a reflector element. Now, I'll use this one for example. Now, this was supposed to be a 15 decibel gain, 2.4 gigahertz Yagi antenna. What this consists of is, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 parasitic elements. All of these elements are called parasitic elements. What their job is to function as reflectors. Now, each one of them is 5% smaller than the one behind it. So this one is 5% smaller than this one. This one is 5% smaller than this one, and so forth, and so forth, and so forth. And what these are going to do is it's going to manipulate your radiation field, your estimated radiation pattern, your ERP, or your radio field, and as the radio waves hit, it's going to reflect it to the next one back in a domino fashion. So all of these are going to want to pick up radio signals from all positions. And then you're going to have the second to last element right here. I'll try to get a nice picture. That right there that I'm wiggling, that is going to be your dipole, your driven element. Your driven element, as you should know by now, is your active receiving portion of the antenna. This is what's going to hook into the coax and feed the signal to and from your actual transceiver, in this case a Wi-Fi card. And then this last element right back here, that's a reflector for any radio waves that might have actually skipped past all of the parasitic elements. Now, as with all antennas, depending on your frequency will determine the actual size of your antenna. Now, I'll put a lot of information in the show notes on how to actually calculate your antennas and wiki articles and even online calculators that do all the thinking for you. But up until this point, we've only really worked with one type of dipole, which is just a typical dipole, which means you have a wire going one way horizontally and then the other way with no significant gap in the middle, or vertically. With some antennas, there is a folded dipole, and a folded dipole means it's an actual loop. The distance between the loop and the size of the loop and the arc and the bends and all that stuff will actually change the impedance of the actual signal. And the impedance needs to be matched to the actual coax, so the coax does not resist the flow of the electrons through the actual cable, which is why you need to get good coax. You can't use shitty stuff. Now, this Yagi antenna was actually quite forgiving. This was designed for the amateur radio 70 centimeter band. It's beat up, it's fugly, and it's literally half-assed, but it works, and it works really well. It gives me 6 decibels of gain on the amateur radio 70 centimeter band, which falls in the 440 megahertz range. Each one of these parasitic elements is literally just, sorry, these two are parasitic elements right here. This is literally household electrical wiring. It's either 14 or 16 gauge copper wire, and it's literally just stapled to a piece of old wood. All of this junk was laying in my lab. Then we have a couple of a standard dipole that is matched to the center frequency, and then we have our back reflector right over here. And this will comprise a relatively portable Yagi antenna, and it feeds to my coax and down to my radio. And of course, because this is at 450 megahertz, and this is at 2,400, you can suspect if you were to make one of these 15 elements, it would come out to about roughly 6 feet long. It's not something quite handheld as a 2.4 gig. But the measurements on these are a lot more forgiving because it's a lower frequency and you can be off center frequency with your measurements. Now, as for building them, I'll give you a couple of tips that I use for building all of my Yagis despite whether they work or not. Try to work with some kind of flat piece of wood. Now, it does not matter if your material, this piece right here, which is called the boom, which is the piece that holds all of the elements, is conductive or not. That'll just determine on which types of calculations you have to make. If you do have a conductive piece of material, that's electrically conductive, of course, a piece of metal, aluminum, steel, copper, brass, whatever. If it's electrically conductive, it cannot be touching your driven element. So, folded dipole or not, you have to isolate your driven element from the conductive boom. This is why I typically stick with wood or plastic. It's just a lot easier to try to not get it to conduct. Now, any kind of wire will work. On this antenna, which is actually the exact copy of this. This was just made out of 3mm strips of aluminum. This was made out of 3mm diameter brass rod. I got that. You can get it at most hardware stores. If you don't have any, you could use, where is it? Old wiring you get out of your house, 16, 14 gauge solid copper wire. Or you could use old coat hangers, which is what I used for this little son of a bitch. Now, with this one was a pain in the ass because trying to drill holes on a round pipe completely straight with any kind of drill is extremely excruciating. It's very difficult to do. So if you can get some kind of square structure instead of a round wood, definitely recommended. So I got some old wood laying around the lab and I drilled all the holes. You can also use plexiglass, but plexiglass is a little flimsy and it really won't stand up to a lot of wind, so if you want to put it outside, it's really not going to hold up too well. But it's really good for handheld stuff because it's really light. As you can see, this thing probably weighs about 4 or 5 ounces. I mean, I can throw this thing across the room and no problem. This, on the other hand, weighs close to about 1.5 pounds. So, now, as for drilling the holes, I've actually created a kind of funky device. This is a typical router accessory attachment for my rotary tool, the Dremel, which, you know, most of you should have something similar. And there's supposed to be a screw or a bolt right here that actually locks it into a specific depth. This is used for actually routing the grout on your tile work or actually routing finishing touches on wood. I actually got myself a spring. This spring was actually salvaged from an old standing fan, like the adjustable kind. So now I actually have something that I can push in and auto-return. So what I can do is I can actually lay this in a clamp, put this down, and when I push on it, drill through it, and then it automatically returns, or at least make some kind of punch into the wood, and then come by again with the Dremel or a slow drill or whatever, and then continue to go into it. Now, this really was easy as sin to make. It was, if I can get the damn thing apart. Like I said, it's just a spring. If you can find one, I'm sure you can improvise something. You're watching BSoD, you probably have an IQ above room temperature by now. And then we have the Dremel accessory. So, that's about that. If you have access to a drill press, you can actually talk to Nate. He did have access to a drill. I had access to a drill press, and I still wasn't able to get all the holes drilled properly. For 2.4 gig, it's just a real pain in the ass. Now, I've also been developing this method, which is the aluminum foil and plastic technique. This is a 915 megahertz Yagi antenna, a parasitic element, parasitic, driven element, which, if you can see, is just a standard dipole. There's no fold in it, doesn't wrap around. And then here is our reflector, which leads into my radio scanner. It's also in a nice handheld form, so it's relatively light, it's got some mass to it, it's got some structure, it's a little bulky, it's a prototype, but it works really well. Now, all I did was take 3mm wide aluminum tape. I calculated my antenna dimensions and the impedance level of the coax and what frequency I wanted it for, and I just used these strips of metal, precisely calculated, on the actual plexiglass, and I cut the plexiglass to shape. I have better pictures of this thing on my Picasa page. If you're interested, I can put links. As well as this son of a bitch right here. I mean, it's the same principle. It's just, the reason this one really didn't work primarily was because the tape itself had to be cut by hand, and it was cut wrong. So they're not all exactly 3mm widths. On this, it doesn't matter so much because it's a lower frequency. It's more forgiving towards mistakes. This, on the other hand, you got to be dead on. And then I know for a fact that the actual 5% width, increase of width on each one of the parasitic elements is not accurately measured. Now, I'm going to take another whack at this one. I have some more time in the next couple of weeks, and I'll post some conclusions on whether or not this 2.4 gigahertz design will or will not work. Right now, this does not work. Right now, for me, this does not work. Now, if you have access to machine shop tools or any kind of precision machine stamping tools, you're really, really patient with a Dremel, I'd really suggest tackling this project. If you're impatient like me and you really don't have the desire or the care to make such a large antenna, I mean, this thing is supposed to yield 15 decibels of gain. But then again, the biquad that I did a couple of segments ago, that will yield about 12 decibels of gain. The biquad is, in my opinion, easier to make. Parts are more readily available. It's a bit more versatile. The Yagi, on the other hand, if you got access to machine shop manufacturing processes, can be easily mass-produced by the thousands, by the hour. It's just a matter of trying to get that folded dipole or your standard dipole isolated if you have an actual metallic conductive boom. So this will pretty much conclude my segment. I'll put a lot in my show notes. I really don't know what else to say. I really hope I didn't discern you from trying to make a Yagi antenna. But to tell you the truth, in my personal opinion, if you want a Yagi antenna for the higher frequencies like 2.4 gigahertz, you're honestly better off buying one professionally manufactured rather than trying to build it yourself. Go ahead and try it. If it works for you, congratulations. That's great. I'd really love to hear your build process. Take lots of pictures. Let us know how it goes. But for me, I think I'm done for it with them. 2.4 gigahertz Yagis, sorry. Too hard for me to make.